Okay, so we're gonna do some definitions here. So what's a parabola? That's the graph of a quadratic function. Sorry, pen's not on. So the graph of a quadratic function is called a parabola. It's that U shape that we see over here. The parent function for a quadratic function is just f of x. Oops. Or y equals x squared. Okay, so just that's what a quadratic function looks like at its most basic level. The vertex of a parabola, vertex of a quadratic function is that point down here. Okay, it's labeled there for you. It's either the lowest or the highest point, depending on how the parabola is oriented, of the parabola. I heard a chat pop up. I need to look at it in a sec. Chat, where are you? Oh, excellent. Yeah, thanks, Stella. You can't in DocHub like make it do that. What you would probably want to write would be X, and then if you hit Shift 6, it gives you a little caret, and then it will look like that. I don't know why I wrote a 6. You just have to read that as an exponent. So there's no way to, in DocHub, actually type an exponent. Lots of other programs have ways of typing them. That one doesn't have that functionality, at least that I saw as I was glancing at it. But yeah, you just kind of gotta make it work. And then the axis of symmetry is the line, or that line of symmetry. Right? It's a vertical line. That divides the graph into even parts, or even halves or something like that. But you can just see that here's our axis of symmetry, and the axis of symmetry is always a dashed line because it's not actually there. It's something that we put in. So there's not actually points there, like that have value. It's something that we put in to help us see things. Okay, so it's purely visual. So it's always dashed. Okay, you can see that if I compare the sides of they're just reflected. So it's like a mirror that the left side and the right side are the same. That's that symmetry, right? And symmetry is something you guys should have talked about in geometry. It's something you guys should have talked about in like biology. That like as an organism, we have bilateral symmetry. So if you cut yourself down the middle this way, your sides are pretty much the same. So here they'd be exactly the same. This next part, the vertex form of a quadratic function. I wrote this down for you guys yesterday, but I didn't really like highlight it too much, but this is something you're definitely going to want to know. So f of x equals a times x minus h squared plus k. So I wrote that on the back of the notes yesterday, just at the top, like as I was kind of talking about stuff. So you might not have written it down, but here you definitely want to get that written down. We're going to be using this a lot, and this form is going to be, I could change this very easily to a cube and have it do all the exact same stuff, or I could put a square root on top of it instead of a square, and it would still do the same thing. So this form of the equation is going to be used a lot for different functions, like we saw it yesterday with the absolute value. Just had absolute value bars around it instead of parentheses and a square. Okay, but the a, the h, and the k are always there for us. So the vertex, where did I find the vertex? Well, remember the vertex is supposed to be at 0, 0 for the parent function. But if we drag it around, so this graph has been shifted to the right 1 and down 4. So now its vertex is at negative 1, 4. Well, here's my left shift and right shift. Here's my up and down shift. So those numbers there the h value and the k value will tell you where the vertex is, okay? When you're looking at a problem like this, guys, the vertex should not be a question you have trouble answering. You should be able to look at that and tell me the vertex very quickly. It's like if I gave you guys an equation like this and said, hey, what's the slope of that line? Or hey, what's the y-intercept of that line? The information is just right there, sitting there, waiting for you to pull it out, okay? This is the vertex form of this function. It tells you the vertex when you look at it, okay? The only thing we have to worry about is h, because what's h? What did we talk about h yesterday? Anybody? Anybody?
Liar.
H is a liar, right? So what does that mean, right? If that doesn't make sense to you, okay, if that's not going to make sense to you about what that means, then don't write that down. Okay? What is it about h, right? It's going to say x minus 5 or something like that, but we have to remember that's actually a positive 5. Or it's going to say x plus 2, but we have to remember that's actually a negative 2. So there's that sign switch between what it says here and what we write here, or what we see on the graph, okay? So these two things are going to match. Here's my h value at 1. It's going to say that here, and then it'll see that over here. But this would say minus 1, okay? K we trust. That would have said minus 4 here. This would say minus 4 here, and then we plot it over here at negative 4. Okay, but this one would say minus 1. We have to remember that's actually a positive 1, and so we'd plot it at positive 1. Okay, so sign switch between here and here. And it's because of this minus sign. That's why it's happening. And the last one is the axis of symmetry. Remember, it's a line. It needs to be an equation. So I'm expecting you guys to write x equals. Okay, it needs to be an equation. Remember, it's an x line because every single point on that vertical line has the same x coordinate. And so that's what defines it, is that all of the x's are 1 in that case, but really it's x equals h. So again, this should never be hiding from you because you're always going to know your h value as soon as you look at the equation. It's sitting right there. So these two things shouldn't be hiding from you. They're just information that's built within the problem. You should just pull right out, okay? This form is very specifically written to give us that information so we can start to graph it. In the same way that the slope-intercept form is very specifically written to give us the slope, give us the y-intercept so we can start graphing the line. Okay? Is there anything? We're going to do some examples. Again, when we get to this sketching part, those of you guys that are trying to do it on the Doc Hub may want to skip that. If you really feel like the sketching is going to be helpful for you, there is a way to do it. I was able to kind of muddle through it with using the little pen tool and stuff like that. It wasn't beautiful, but we're just doing sketches anyways. My graphs aren't going to be beautiful. Okay. But definitely doing the other parts, as you type those out, it should be easy enough to do. Is there anything you guys want me to talk about before we look at a couple examples? So there's 3 things they want us to do. It's describe the transformations. We were talking about that yesterday. That shouldn't be too wild. We're going to identify the vertex. That's kind of newer for us today. We're going to identify the axis of symmetry, and we're going to do that sketch. So 3 things they want us to write out, and then we're going to sketch it. But the transformations, looking at this minus 5 inside of the function like that. Connor, what do you think that minus 5 inside of the function there is going to do for us? How's it going to change the graph?
Would it just like make it so that it's like negative and it's like below the axis?
What did the values inside do yesterday?
Didn't they like change to positive?
So yeah, we do need to change that sign. Then which way is it going to move? All right, so now that we know it's going to be actually, it's acting like a plus 5, which way is it move?
To the left.
Is left a plus way? Right? We know that it's actually a plus 5. We see it says minus 5. We know it needs to act like a plus 5. And so then plus would be to the right.
Oh, okay.
So seeing that, right? So the ones inside were our left and right shifts, but we knew that we had to watch the sign on them. They were going to lie to us, right? And then the ones after, kind of like the 7 over here, were the up and down shifts. So the inside is our left and rights. The ones outsides are our up and downs. So we're seeing that as an inside on the 5. So we're going to think about it as a left or right. But remember, it lies to us. So that's going to be a shift right 5 units. Okay. Good, right? Good, Amaya. Good, Tatum. And the chat there, I see. Now, there's nothing else going on here. There's no numbers in front. There's no numbers after. So if it's not happening, if it's not being written out there, then I don't want you guys talking about it. Like you wouldn't say it's being stretched by a factor of 1. Multiplying something by 1 doesn't make it any bigger or smaller, so we don't talk about that. We wouldn't say it's shifting up 0. That doesn't make sense, right? That's not actually a move. So if it's not happening, I don't want you guys talking about it. Okay, so we're only going to mention the things that are different than the parent function. So this minus 5 is different, so we need to talk about it. Okay, so that's the only transformation there to talk about. And then we move on to the vertex. Okay, the vertex is at a point. We need to identify where it is. Remember, those values are right here and right here, our h and our k values. So how is it moving horizontally? How is it moving in the x direction? That's that shift right. So that's that positive 5. Okay, well, how's it moving up and down? Well, it's not moving up and down because there's a 0 back there. So then the vertex would still be at 5, vertically at 0. Okay, so I'm just pulling those numbers right out of the problem. They're just sitting there. Okay.
Why did you make it positive 5?
Because h is a liar, right? It was a shift right. If it was negative 5, then it would have been over here on the left side, Peyton, right?
Yeah.
It's being shifted to the right, though. It's over here on the right side. Okay, so h is a liar. We see it. It says minus 5, but we need to read it as a shift right towards the positive side. Okay, it's always going to do that. If this had said plus 5, then this would have said minus 5. Okay, you're always going to change that. And the last thing is the axis of symmetry. I'm going to abbreviate that a little bit. Remember, the axis of symmetry is an equation. It's always going to be a vertical line, so you're always going to write x equals. Well, what's x equal to here? Again, it should not be a mystery. It's right there. These will always be the same. Okay? Direct connection between where the vertex is and the axis of symmetry, because the vertex will always lie on that line. That has to have the same x value. Okay? So these two pieces of information should not be guesses, guys. They're just there. You read the problem, you see the numbers, pull them down here. That number will always go there. So if you know this, that means you know this. If you know this, that means you know this. Because they're the same. So I've guessed where, I'm just taking a guess where 5, 0 would be. Okay, you just kind of eyeball that wherever you feel like 5 is for you. Okay, so there's my vertex. I'm going to label that with a V. I'm going to draw, sketch in my axis of symmetry, just a vertical line through there. Again, if doing all of this is too much, if you can just manage to draw the curve, then just draw the curve. But it should look something kind of like this. Just a smooth U shape going through, hitting down there at 5, 0, then bouncing back up. The parent function would have looked like this. Ooh, that's rough. Okay, that would be plain old x squared. But here is x minus 5 squared. Okay, so we see that shift right.
Okay, I get it now.
Who is that? Connor?
Okay. That was Connor.
Yeah. Always takes just a couple of seconds to let me know who's talking. Okay, so there's our beginning one. I'm going to ask you guys more questions on this next one. Kind of use that as our model, though, to go off of. Okay. Let's see. Lucas, can you look at this B here and pick one of the transformations that you want to talk about?
Oh, I can talk about the -7.
Okay, what's the -7 doing?
It could parabola it down.
Okay. So you said move. What's another verb we could use instead of move?
Shift.
Shift. Okay. Again, I think the textbook is using the word translate. Okay, so maybe you want to write that down just to get that they mean the same thing. Translate would probably is what you guys use in geometry. Down 7 units. Okay, thanks, Lucas. Brooklyn, what about, is there something else you could, because there's something else that you could pick out to talk about?
I think that the one word means vertical compression, right?
Okay. So vertical, you got that right. It was compression. I like that you said vertical. The number's less than 1, so that fraction were the compressions. There was some language I asked you guys to use, a phrase that I asked you guys to do. I see it, Jasmine.
By a factor of 1/3.
By a factor of 1/3. Great. Of 1/3. Okay, awesome, Brooklyn. Thank you. Ty, what about that +1? What's that +1 doing for us? +1, parentheses, shift left 1 units, he's saying in the chat. So awesome. Shift left 1. So he got the sign switch there, right? It says +1. We're going to treat it like a -1, though. Okay, so we've talked about all the different transformations. We've hit them all, right? So what's different, right? So there was a number in the front, there was a number inside the parentheses, and there was a number after the parentheses. That's really like, I think there's one other thing we could add in there to make it like the full gamut of everything. And we saw that on that last problem we were doing on the online homework there. That last one we were doing, it had everything. So the only thing I'm not seeing here is a reflection. So it's really like this is a pretty big problem, and we're able to identify all those pieces. That's good. So now the vertex. So where's our vertex? We should be able to look at this problem and say, boom, there's my vertex. Should be able to pick it out real fast. It just tells us. So where's our vertex? Avery, where's our vertex?
Vertex again? Isn't that the point at the bottom?
Mm-hmm. So we did it over here. Oops. No. We found the vertex at 5, 0 over here.
Okay, so would this one be -1, 0?
Not -1, 0. Where did I get the 0 from?
I,
Where did that 0 come from? It came from right here, right? Since there was no number here, I put a 0. So what's the number on B?
-1, -7 or 7?
Oh, yeah, -7, right? So remember, H is a liar, so we need to switch the sign like you did, but we trust K. So we just bring down the number that's there. Great. Okay. So there's our vertex. And so, that's something maybe we want to go, if you're going to do the sketch, like, okay, I just kind of guess where -1, -7 is. So I want to go to the left a little bit and then, down a pretty good ways. And so I'd say, okay, there's my vertex. I'm going to give that a V next to it just to highlight it. All right, last piece of information here is the axis of symmetry. So where's our axis? Needham, where would the axis of symmetry be?
What is
Close.
or -1?
-1. How do you know it's -1?
Because when you have to where the x plus 1 is, switch that, so it's -1.
Okay, good. Yeah. There's just one other thing I want you to say, right? How do we write axis of symmetry, right? It's always written this way. So it needs to be written as an equation. So don't just say it's -1, say it's x equals -1. Because we need to kind of emphasize that it's a line, not just a point. So we'll give it an equation. Okay, cool beans. But again, it shouldn't really be a big guess because it's always the same as the x value of your vertex. These two numbers will always match. So I'm going to sketch that in. So they're at -1. All right, one last question for you guys. what did the vertical compressions do to the graph? How did they change the way they looked? When we compressed the graph vertically, how did it look different than the parent function? I'm just going to throw that out to the group. How did a vertical compression look different than the parent function? About that silly putty, right? When you compress the silly putty, what does it do?
Stretches it.
If we compress it, right? So compressing is the opposite of stretching. Right? So what did it look like when we compress the silly putty? When we compress the graph, how did it look different? Gets squashed, yeah, but what did it look like, Clover, when you compared the two graphs to each other visually? So Maya, you're saying it looks more narrow. So think if you take a silly putty, you take a rubber band and you stretch it, that's when it would get narrower. Okay. So if we take that silly putty and we squish it down, what would it do? Yeah, it should get wider. Okay, I see what you're saying there, Ty, about Jasmine. Thank you. So if I'm going to show that it looks wider, all right, so if I think about how I drew this one over here, I would want to draw it wider than that. Again, this is all just kind of a sketch, right? I'm just going to draw something wider than that one since we're not doing any like specific math. So just kind of trying to highlight that this graph should be a wide parabola. Okay, so it would look kind of like that. Okay, so again, just comparing, right? It's all about comparisons. Like it looks wider than this one. That's what we're after. Okay, so all right, so seeing that. All right, so if you can just again think about squishing down something, that it would have to expand to the sides as we compress the graph. Okay, so that's kind of a big problem. Is there anything there you guys want to talk about before we move on to the next one? Oh, I know we're about to run out of time too. Oh, actually, let me flip to the back since we are about out of time. I want you guys to see this. So this is the other side of it, right? And this is really what math is more about, that if we don't just have equations sitting around waiting for us to use them. Okay, if you're an engineer or something like that and you're designing something, you have to write the equation yourself. And so it's all about like trying to fit like needs, right? What do I need this curve to do? Okay, I need it to be wider. I need it to go through this specific point. And so that's what they're really after here, is they're giving us a shape that they want us to use. Well, they're saying here, let's use a parabola, but I want that parabola to be stretched by a factor of 1.5. I need it to be stretched out. And I also need it to be shifted left 6. I'm trying to get a specific shape drawn, right? If you're into computer gaming or computer programming, like it's this thinking that allows you to code something. Here's, I need this function to do this instead. So how do I change the math to make it do that? Well, we're using this form. Our vertex form. Okay. Well, remember where stretches happen. Okay. Stretches happen with the A. Where do left and right shifts happen? Left and right shifts happen with H, but we watch out for that liar. Where do our up and down shifts happen? They happen back here with K. So if I see an up and down shift, that's the number I need to change. So if I'm going to write this function, I'm going to start off when they want us to say g of x. So g of x would be equal, I'm going to start off with that x squared. Okay. Well, they want me to change a, so that's 1.5. So I'm going to put a 1.5 here. And they want me to change h, so it's -6, right? It's a left shift. Well, remember what happens from here to here, we have to switch the sign. H is equal to -6, but when we go to write it here in the function, we have to write +6 because of that sign switch, because H is a liar. Okay, the way it talks to us here is different than its actual value. Left is a negative number. Okay, but when we see it here, because of that minus sign that's already there, that double minus, this is part of the y, gives it turned to a plus. Okay, so I'm just switching the sign from here to here. I'll do this last one real quick. If you guys did the homework already last night, if you finished it, then you're good for tonight. If you didn't finish it last night, If you wanted to try to go back and fix a problem or two or something like that, then you certainly could do that tonight. But if you finished it last night and you're good to go, then you don't need to do anything tonight. But the half of you that didn't do that, I need you guys to step up and get that done. Okay, so I'm starting with my shell, x squared. A reflection, remember that's a negative, and that goes in the front. Here's saying a vertical shrink by a factor of 1/4. So that'd be a of 1/4. Where's a? That's in front. Shift 2 units up. Up is my k value. So k is 2. We trust k. So I put a +2 back there. So technically, I don't need these parentheses. So if I was going to write this the simplest way possible, it would just look like this. Oops. Because there's nothing happening left to right, so I don't need anything in there with the x. Okay. So I should look, let me move this over so it looks more normal. That's the way it should be written. Since there's no left to right shift, I don't have anything inside with the x. Tatum, I'm not sure why you put the +6. Wait, oh, you did the first one. Okay. Yeah. Okay. You guys good on what I need from you for tonight?